How do you make comparisons between an equation and a table? For instance, y equals negative 2x plus 1 and the corresponding table at the right. In this lesson, you will learn how to compare two functions by analyzing an equation and a table. So the equation of one and the table of the other. Let's review. A table is a numeric representation of inputs and outputs of a function relation. Remember, there's four representations of any given function that you can make. A table, a numeric, algebraic, graphic, and verbal. So a table is just one, it's a numeric representation. So given these inputs and outputs, we can make a table. An equation is an algebraic representation of a function relation. So given the same inputs and outputs, we notice that the output is equal to 2 times the input. If we replace input and output with x and y, we get y equals 2 times x. One common mistake that I've seen is to check for the constant rate of change, or to check for a rate of change, is to only check the change in the y values in a table. For instance, 18 minus 14 or 14 minus 10. 3 consecutive y values, if we subtract those as well, we'll get 4 both times. Well, we might think the constant rate of change of this table is 4. Well, that's incorrect. Remember, the constant rate of change is the change in y values divided by the change in x values. Notice on the left side of the table, the input is not changing by 1. So, we would say 18 minus 14 divided by 9 minus 7, which is 4 divided by 2, which is 2. Let's check the other one. 14 minus 10 divided by 7 minus 5. That's also 4 divided by 2, which is 2. So the constant rate of change of this table is 2. Let's check a real example. California offers 5 cents, for every soda can brought in to recycle. So if we let the cans be our x, our input, and the money be our output, we have 1 can is worth 5 cents, 2 cans 10 cents, 3 cans 15 cents. So the constant rate of change here is 5 cents. Every can you bring in, you get 5 more cents. So for an equation, it's y equals 5 cents times x. Across the map, Michigan offers 10 cents for every soda can brought in to recycle. Again, we let our input be our cans, our output be our money. 1 can gets 10 cents, 2 cans will bring you 20 cents, and 3 cans will bring you 30 cents, so on and so forth. To make a table out of that, this is the numeric representation of this situation. So we see varying amounts of cans and the amount of money that each amount of cans will bring in. So let's compare. We have an equation and a table. Well, each one is a function. How do I know that? Well, to be a function, each input has exactly 1 output. So I know that every amount of soda can I bring in is going to give me 1 output. They're both 1-to-1. Why is that? Well, to be 1-to-1, each input has to have a unique output. So if I bring in 1 can for California, I know I'm only going to get 5 cents back. If I bring in 1 can for Michigan, I'm only going to get 10 cents back. I'm not going to get for 2 cans, I'm also not going to get 10 cents, or 3 cans, I'm not going to get 10 cents. So they don't share outputs. Each output is unique. Lastly, the constant rate of change for California is 0.05, or 5 cents. We can tell that because it's the coefficient of the independent variable. On a table, the constant rate of change here, we check the change in y divided by the change in x. So it's 10 cents. Every time you bring in a can, the money goes up 10 cents. So if I have a table here, just to reiterate, to check the rate of change, you want to do the change in y divided by the change in x. So if I take negative 2 and 4, so I take negative 2 minus 4 divided by the x value, 6 minus 3. That gives me negative 6 divided by 3, which is negative 2. And if I did that for the rest of the values in the table, I would also get the same thing. The constant rate of change here is negative 2. So in this lesson, you have learned how to compare two functions by analyzing an equation and a table.